air,
Why?
liquid, and a solid.
Right, that's what I'm thinking. Yeah, that's why I was thinking.
No. Somebody want to give me their prediction and tell me why they think? Faster, the same, slower?
Slower, because it's something about more particles.
The particles would be packed closer in a solid than they would be in
So
gas.
sort of more inertia, more particles to wiggle, right? Okay. Anybody else have a different prediction? Don't be
I
shy.
think it's gonna be faster.
You think it's be faster, okay? And I think my seismometer keeps falling over on me. Why this experiment?
Particles get so close to each other, they can vibrate, and if the air particles are further apart, we don't know if we're right or not. We'll guess.
What's that? Sorry, I didn't quite follow.
And so all of the particles are closer together than they are in a gas, in the air. And so the vibration will
Be faster.
particles that are close together.
Same-
But we could be wrong.
Same reason.
Same argument
Like
for both cases.
conduction of
Understand the
heat.
conduction of
Yeah.
So I heard slower, faster. Did anybody say the same? Anybody go with that? How many people say slower? Raise your hand, don't be shy. Okay, looks like about, and how many say faster? So it's about even, I'd say, right? Okay, so we can see for real here. I'm gonna clear this last data, just because it's gonna be hard to see
Smart
things.
kids, did you guys hear
Okay, so now I get to simulate what you guys are gonna be doing out there with the sledgehammer, only I'm gonna do it in the table and I'm gonna use my version of the sledgehammer. Just anything hard.
But
to
can
tap
sound
the
go through solids farther than it can go through liquids?
I would say that sound travels farther through solids than it does through liquids and then air. I mean, basically,
So it can go farther in liquids than air, right? And
which
so
is
it
why
can
we
go-
can see earthquakes in Iran with seismometers.
Right, so it can go farther in solids than it can in liquids.
Yeah, I think so.
Okay,
go
I don't know,
with
that's why I started thinking solid.
Yeah.
Well, there's more continuous solid than there is continuous liquid.
So, that's a complicated question.
Depends what kind of solid.
But the
But if
speed,
you said like
I'm
a
thinking
good
it's-
solid and the oceans, they're probably similar distances. Even the earthquake in Iran generates sonic waves in the atmosphere. And so early on when they were, even now, when they try to verify nuclear tests, they listen to the atmosphere as well as they do the ground. And then if you wanted to get complicated, you could, but generally speaking, if they're both solids that don't have high temperatures, it could, when you get to high temperatures, things attenuate. There's frictional energy loss. But if it's a normal solid, normal liquid, similar distances.
Okay, so somebody else can be the tapper. There you are. And you're going to try to tap it near this one. Now, just notice that you don't have to tap it very hard, I found. Notice that all I did was take these microphones and tape them, duct tape them to listen to the table. And I can tell you from experience that it sometimes takes a lot of duct tape to get them to stay still, especially so all I got to do is go ahead, can you see all that? And just say go, and that's waiting for a trigger. Go ahead. Okay.
Tapped it twice.
And you can see even with that, it's a huge signal relative to that signal in the air, right? And so it's actually sort of saturated, if you will. But we're going to go with it anyway. All right. So again, all I need to do is go analyze, examine. And see, I did just what I said not to do. Which
You didn't
is I didn't
stop
stop it. So now we got to do it again. Okay.
I just,
Make it slower this time.
Okay. I need my tapper back.
all right, just a second, we're just going through some busy work here. Paperwork.
That's our patiently waiting for the signal, and that's oops.
It hurt
Go
her.
ahead. Okay, got it. I've done that to myself so many times. It's like, oh yeah, here we go. Boom, it's gone. Okay, integral, analyze, examine. Excuse me. So I kind of like that. Right there is a good pick for the start of the signal on the red microphone, the close microphone. Negative 0.0008 seconds, and it's interesting to me that it went the opposite way over here. 0.0015 seconds.
Why are you measuring from there?
Repeating patterns.
Because you want it to be a repeating pattern, right?
Yeah, well, but it's actually flipped, all right. It's complicated in a table because you get reflections off the edge of the table. If you do this in a nice 2-meter long classroom table like I normally do, you'll get better results. But if you do it in a table that's just barely a meter long, then unfortunately things go and bounce off the edges and come along and kind of mess your signal up. So that's this kind of explanation, right? But anyway, so 0.0015, and the other one was minus 0.0008, so that's about 0.0023, which, remember the last one was 0.0029, so it's shorter, so is it faster or is it slower?
Faster.
Faster. Explain your reasoning.
Those particles.
Well, it got there in less time, so it's faster.
Okay, got there in less time. But I would take 1 divided by 0.0023, right?
You didn't really
And
want
that
to
would
hear
give
that,
me a
did
bigger
you?
number?
Okay.
So here's what I'm getting at, is this notion of
Supposed to do
proportional
math today.
reasoning, inverse proportional reasoning. Well, students have trouble with in math. You know it, right? The thing in the denominator gets smaller, so the velocity gets bigger. And that's just what happened here. So this is an opportunity to maybe talk about that. You sort of reasoned it out sort of in a different intellectual style or whatever. That's just, well, it took less time, it's faster, you know. But just remember that that's what you're doing, okay?
Okay.
Just remember
So
the math.
Doug, did I have anything else to do here? Or are we going to go back to you at this? Oh, I was going to go
Yeah,
to
I don't
that.
know how, it's 10 after 4, and we want to be done by 5:30.
Okay, maybe we should go ahead and split and
I would
start.
say a little bit about site response.
Okay,
So
I'll get you set
because I
up.
think this does a nice thing about waves and stuff. And I'll just do a couple of slides on site response, so you can know what we mean by that.
Okay,